Download this code from codegive.com, link in the description below. OK, let's dive into the intricate world of handling login errors. This tutorial will cover various aspects, from understanding common error causes to implementing robust error handling in your code, focusing on the scenario where an error occurs during the login process itself. We'll explore code examples in Python, with Flask and potentially Django, as well as general concepts that apply across different languages and frameworks. Understanding the landscape, common login error causes. Before we can effectively handle errors, we need to know what can go wrong. Login errors are generally caused by the following categories. Invalid credentials. This is the most common. Incorrect username/email. The user enters a username or email that doesn't exist in the database. Incorrect password. The user provides the wrong password for the given username/email. This can include case sensitivity issues or typos. Account issues. Account not activated. The user may have registered but hasn't clicked the activation link sent to their email. Account locked. Too many failed login attempts can trigger a lockout mechanism to prevent brute force attacks. Account disabled. An administrator might have disabled the account. Account deleted. The account may have been deleted. Network and connectivity issues. No internet connection. The user's device is not connected to the internet, preventing communication with the server. Server unavailable. The server is down for maintenance or experiencing technical difficulties. Firewall/proxy issues. A firewall or proxy server might be blocking the connection. Authentication system errors. Database connection errors. The application can't connect to the database to verify credentials. Hashing algorithm problems. The hashing algorithm used to store passwords might be misconfigured or broken. Session management issues. Problems creating or managing user sessions after successful authentication. Token issues, example JWT. If using JSON web tokens, JWTs, problems might arise during token creation, verification, or expiry. Security issues. Cross-site scripting, XSS vulnerabilities in the login form could allow attackers to inject malicious scripts. Cross-site request forgery, CSRF attackers might trick users into unknowingly submitting login requests. Proper CSRF protection is crucial. Brute force attacks. Repeated login attempts could indicate an attack, and measures need to be in place to mitigate this. Implementation errors, code bugs. Incorrect query logic. Bugs in the code that queries the database for user information. Faulty password verification. Errors in the password hashing and comparison logic. Incorrect session handling. Issues with setting or retrieving user sessions. Input validation issues. Missing input. Required fields might be empty. Invalid input format. Email addresses might be in an invalid format. SQL injection. Improperly sanitized input could allow attackers to inject SQL code. Third-party authentication errors, OAuth, social login. API connection issues. Problems connecting to the third-party authentication provider, example Google, Facebook. User permission issues. The user might not have granted the necessary permissions to the application. Token expiration. Tokens from the third-party provider might have expired. 2. Error handling principles and best practices. Effective error handling is essential for a good user experience and a secure application. Here are some core principles. 1. Graceful degradation *. When an error occurs, the application shouldn't crash or display cryptic error messages. Instead, it should provide a user-friendly explanation and guide the user towards a solution. 2. Informative error messages *. Error messages should be clear and concise, telling the user what went wrong without revealing sensitive information that could be exploited by attackers. For example, instead of invalid username or password, you might say, the username or password you entered is incorrect. 3. Logging *. Log errors on the server side to help developers diagnose and fix problems. Include relevant information like the user's IP address, timestamp, error message, and stack trace. Be careful not to log sensitive information like passwords. 4. Centralized error handling *. Use a centralized error handling mechanism, example try except blocks, error handling middleware, to avoid duplicating error handling code throughout the application. 5. Security considerations *. Avoid displaying sensitive information *. Don't expose database queries, stack traces, or other sensitive details in error messages to the user. Rate limiting *. Implement rate limiting to prevent brute force attacks. Limit the number of login attempts allowed within a certain time frame. Input validation *. Thoroughly validate user input to prevent SQL injection and other vulnerabilities. 6. Retry mechanisms, where appropriate for transient errors, example temporary network issues, consider implementing retry mechanisms with exponential backoff to automatically attempt the operation again. 3. Code examples, Python with Flask. Let's create a simplified Flask application with login functionality and error handling. Explanation of the code *. Flask setup * imports necessary Flask modules and initializes the app. Database connection * get_db_ connection, provides a database connection using SQLite, for simplicity. In a real application, use a more robust database like PostgreSQL or MySQL. Database initialization * init_db, creates the user's table if it doesn't exist. Registration, /register. Handles user registration. Hashes the password using bcrypt before storing it in the database. Uses a try, except block to catch SQLite3. Integrity error, which occurs if the username or email is already taken. This is a form of specific error handling. Displays appropriate flash messages to the user. Login, /login. Handles user login. Retrieves the user from the database based on the entered username. Uses bcrypt.check_password_hash, to compare the entered password with the hashed password stored in the database. Sets a session variable user_id to indicate that the user is logged in. Crucially, provides specific error messages, incorrect password or username not found. This is better than a generic invalid credentials message. Dashboard, /dashboard, a protected route that requires the user to be logged in. Logout, /logout clears the session and redirects the user to the login page. Error handlers, catches 500 errors and renders a simple template. You'll want to log the error as well. Templates, example. Here's a basic login.html template. Key error handling points in the example *. Try, except block in registration *. Handles the case where the username or email already exists. Specific error messages in login * provides more informative error messages to the user, example incorrect password versus username not found. Asterisk flash messages asterisk uses flask's flash function to display error messages to the user. These messages are displayed in the template. Asterisk session management asterisk uses flask session object to track the logged in user. 4. Handling different error scenarios, advanced examples. Let's expand on the example to handle more specific error scenarios. 1. Account not activated asterisk asterisk. First, add an is_active column to your users table in the database. Modify the registration route to send an activation email. This is a simplified example. You'll need to configure email sending. Explanation of account activation asterisk. 1 is_active column asterisk a Boolean column in the users table indicating whether the account is activated. Default is false. 2 activation token asterisk a unique token generated during registration. In a real application, use a more secure method like Fernet or its dangerous. 3 activation email asterisk an email sent to the user containing a link with the activation token. 4/activate/token route asterisk this route handles the activation link. It verifies the token. In this simplified case, just extracts the user ID, updates the is_active column in the database, and redirects the user to the login page with a success message. 5 login check asterisk the login route now checks the is_active column before allowing the user to log in. If the account is not activated, a flash message is displayed. 2. Account lockout, rate limiting. To prevent brute force attacks, you can implement account lockout after a certain number of failed login attempts. This example uses a simple in-memory dictionary to track failed login attempts, but for a production application, you should use a more persistent store like Redis or a database table. Explanation of account lockout asterisk. 1 max_login_ attempts and lockout_duration asterisk constants that define the maximum number of failed login attempts and the lockout duration. 2 failed_login_ attempts dictionary asterisk a dictionary to store failed login attempts for each username. The dictionary contains the number of attempts and the lockout time, if the account is locked. 3 lockout check asterisk before attempting to log in, the code checks if the account is locked. If it is, a flash message is displayed. 4 incrementing attempts asterisk if the login fails, the code increments the number of failed attempts for the user. 5 lockout asterisk if the number of failed attempts exceeds max_login_ attempts, the account is locked, a lockout_time is set. 6 resetting attempts asterisk on successful login, the failed login attempts are reset. Important notes on lockout asterisk. Asterisk persistent storage asterisk the failed_login_ attempts dictionary is stored in memory, which means it will be reset when the server restarts. For a production application, you must use a persistent store like Redis or a database table to track failed login attempts. Asterisk IP-based rate limiting asterisk you can also implement rate limiting based on IP addresses to prevent attackers from creating multiple accounts and launching brute force attacks. Asterisk CAPTCHA asterisk consider adding a CAPTCHA to the login form to prevent bots from automatically attempting to log in. 3. Database connection errors asterisk asterisk. To handle database connection errors robustly, it's crucial to wrap database operations in try, except blocks and log the errors. Explanation of database error handling asterisk. 1 try, except blocks asterisk the get_db_connection function and all database operations within the login route are wrapped in try, except blocks. 2 logging asterisk if a SQLite3. Error occurs, the error message is logged using applogger.error. This is crucial for debugging. Make sure you have logging configured in your Flask application, see the example. 3. Flash message ***. A generic error message is displayed to the user using Flash. Avoid displaying specific database error details to the user for security reasons. 4. Connection closure ***. The con.close method is called within a finally block to ensure that the database connection is always closed, even if an error occurs. 5. Connection failure handling. The login function checks if get_db_connection was successful before proceeding. If the connection failed, it renders the login template without attempting database operations. V. General considerations and security hardening. Input sanitization / validation. Always sanitize and validate user input on both the client side and server side. Use proper escaping techniques to prevent SQL injection and XSS attacks. Password hashing. Use a strong password hashing algorithm like BCRYPT or Argon2. Store passwords as hashes, never in plain text. Use a library like BCRYPT or passlib to handle password hashing securely. CSRF protection. Implement CSRF protection to prevent attackers from tricking users into unknowingly submitting login requests. Flask provides CSRF protection through the Flask WTF extension. HTTPS. Always use HTTPS to encrypt communication between the client and the server. This protects user credentials from being intercepted. Regular security audits. Conduct regular security audits of your application to identify and fix potential vulnerabilities. Stay up to date. Keep your application dependencies up to date to patch security vulnerabilities. Two-factor authentication. 2FA. Consider implementing 2FA to provide an extra layer of security. Content security policy. CSP. Use CSP to mitigate XSS attacks by controlling the sources from which the browser is allowed to load resources. 6. Django example, login and error handling. Here's a simplified example using Django's built-in authentication system. Explanation of Django example. 1. Authentication form. Django's built-in form for handling login. 2. Authenticate. Django's function for authenticating a user against the database. 3. Login. Django's function for logging in a user, creating a session. 4. Logout. Django's function for logging out a user, destroying the session. 5. Messages framework. Django's built-in messaging framework for displaying success, error, and informational messages to the user. This is similar to Flask's Flash. 6. Form validation. The code checks if the form is valid using form.is_valid. If it's not valid, the error messages are extracted from form.errors and displayed to the user. 7. Logging. Errors are logged using Django's logging system. Error handling in Django. Form validation. Django's forms provide built-in validation. Messages framework. The messages framework is used to display error messages to the user. Logging. Use Django's logging system to log errors on the server side. This helps with debugging and monitoring. 7. Conclusion. Handling login errors effectively is a crucial part of building a secure and user-friendly web application. By understanding the common causes of login errors, implementing robust error handling techniques, and following security best practices, you can create an application that provides a good user experience and is protected against attacks. Remember to always prioritize security and keep your application up to date with the latest security patches. This detailed tutorial provides a solid foundation for understanding and implementing error handling in your login process. Remember to adapt the code examples and techniques to your specific framework, language, and application requirements.